All right. Good morning once again, ladies and gentlemen. Today, what a great day it is. If you don't yet already have, please get out something with which to write and something on which to write, because we get to talk about functions in a new aspect today. It's something that you may have touched on briefly in Algebra 2, but I don't expect you to spend much time on it, and we're going to kind of expand on it a little bit this time. So anyway, today what we are talking about is we are going to talk about combining functions. Okay, we are going to be combining functions. All right, and there's two ways to combine functions. And so we're going to start with the easier one, and then we'll get to the little bit more complicated one. The first way of combining functions, so for number one, is by sums, differences, I think you know where I'm going with this, products, and quotients. And so what does that mean? Well, quotient. There we go. T-I-E-N-T, sorry. All right. Well, when we're combining functions with sums, differences, products, and quotients, what it literally means is that's how we're putting them together. You know, sums refers to something where the result of adding, differences, result of subtracting, product, result of multiplication, and quotient is the result of division. And so that makes basic sense. That's not an overly complicated thing. And so, but I want to illustrate it. And so here's what we're going to do to illustrate it. We're going to come up with two hypothetical functions, okay? And so first we're going to have function f of x. So this is some hypothetical function. We don't even know what it looks like. It's just there is a function f of x. And f of x has a domain. And we're going to call the domain A. Now, that might seem super crazy because you're like, wait, a domain is supposed to be all possible inputs. Well, remember that we could have a set of numbers that we gave a name, like a capital letter A. So here, A is the set of numbers that is the acceptable inputs for function A. That's why it's a domain. A domain is all possible inputs. So A is that set, the only numbers possible that go into the function f. All right. And then we're going to have a function g of x. And likewise, G is going to have a domain of B. I guess I should kind of put a little bit more with that. Let's see, I'll scoot this over and say, with a domain A. Domain A. And then with this one, we're going to have a domain, I'm getting lazy here. That'll make it easy. Okay, so we've got this hypothetical function f that has a domain of A, for whatever numbers that is. We have this other hypothetical function G, which has a domain of B, whichever numbers that is, okay? And so now what I'm going to do, that's what helps us kind of then understand what I'm going to write here on out, because I'm going to write some things with F and with G, and we're going to talk about domain. So I have to at least establish that these are some functions, okay? So some of the notation is going to look a little weird, but it's so easy. This stuff is so simple, okay? We're going to start with the idea of a sum, and that would be like f plus g of x. And that's literally how you'll see it in your book, f plus g of x. Now, here's the good news. It is the simplest thing. You literally take the function f of x, and you simply add g of x. That's it. It's that simple, okay? So then here's the neat thing, though. Now you got to figure out domain. Now, I had a student earlier do a great job of really articulating what the domain would have to be. And she said, well, there's some numbers that go into F and there's these other numbers that go into G. So the only numbers that would work for this, combination would be the overlap numbers for F and for G. And that's exactly right. And how would we describe those? Well, that would be the intersection of A and B. Okay, so what I'm going to do is I'm going to write, I should have put in the word right here. I'm going to write, this is the line over here is going to be like the column for the domain for these functions. Okay, and so the domain for that function would be the intersection of A and B. All right, let's do the next one. So we have f minus g of x. Now again, this is so simple. F minus g of x is just f of x minus g of x. What's the domain? The same. It's the intersection of A and B. Wherever A and B overlap, whatever numbers are in both groups, both sets, those are the numbers that we can put into this. And then we have f times g of x, which is exactly as it sounds, f of x times g of x, and the domain is the intersection of A and B. I mean, this is so simple. And I know right now this might look like, wow, for math class, that has very, very few numbers, meaning none. And so this might seem a little bit odd, but once we kind of give an example, you'll see that this is really simple. So right now, I just need you to understand these basic concepts that when we're talking about f plus g of x, all we're really doing is we're adding the two functions. And when we're talking about f minus g of x, again, all we're really doing is subtracting the two functions. And when we say f times g of x, we're just multiplying the two functions. So then that gets us to the last case, which is going to be division or a quotient. And so we're going to say f divided by g. I write it as a fraction of x. And what is that going to be equal to? Well, then just like all the other ones, so that's going to be equal to f of x divided by g of x. Okay? Now, the question is domain. And this is where we can go a little bit too fast. We can say, well, the domain, it has to be the same as all of them. It's got to be the intersection of A and B, blah, 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 blah. Except we have introduced a new issue with the domain, and that would be this right here. All of a sudden, g of x, the function g of x, is the denominator of a fraction. And so then there's something we got to rule out. And it's not that we have to rule out when x is 0. We have to rule out whenever g of x is 0. So whatever value I would plug into the function that would output a 0 for g, I can't have that because then I would be dividing by 0. Okay, so then that's the domain. All right, so the good news about this is when we're doing these problems, if you take the time to figure out what in the world the domain for f is and whatever the domain for g is, then this is kind of like this formula for how to find the domain of the combination. So that's really, really simple, okay? Let me give you an example. We'll try something. So here we go. Ready? Boom. I hope you have all that. I think we've spent enough time looking at it. All right. All that makes a lot of sense. So now let's combine some actual functions. Instead of talking about hypothetical functions, let's do real ones. So here we go. We're going to do exemple numero uno, okay? An exemple numero uno means, let f of x equal, what do we want f of x to equal? How about 4 over x minus 3? That's not too bad. And g of x to equal, square root of x. That's pretty simple. Okay. And so if that's the case, and then let's say find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. Okay? That's what we're going to do. So we're going to start with this idea that these are the two functions that we're dealing with. We're not dealing with hypothetical functions right now. That is the function f, and that is the function g. Okay, so the best thing for us to do would be right off the bat is go, okay, so if f of x is 4 over x minus 3, let's go ahead and find the domain. So that way I know it ahead of time going into this problem. And so domain, you're always looking for fractions or radicals. This one does not have any radicals, so we're just dealing with fractions. With this fraction, we can't divide by 0. So we know then that this bottom right here cannot equal 0. So we say x minus 3 cannot equal 0, which would mean that x cannot equal 3. Okay, and so that's the domain. The domain is that we're good with all real numbers except for x being 3. Now let's do the same thing for g. So the function g of x is equal to the square root of x. So let's find the domain. Now again, you're always looking for radicals or fractions. This one has no fractions in it, but it has this square root. So we know that everything that goes into there, we can't have any negatives. So x has got to be greater than or equal to 0. You can take the square root of 0. That's okay. All right. So all we did at this point, make sure you're taking stock. All we did at this point is find the domain. We have not done the thing we need to do. We haven't found the sum and the difference and the product and the quotient. So we're going to do those things now. And that's not hard. It's not hard. Okay? Watch. You're going to laugh at how lamely simple this is. Okay? So f plus g of x is literally f 4 over x minus 3 plus g square root of x. And that's it. Now, we should also find their domains, and I didn't put that in the problem, but it will be in all of yours. And so we go, well, what's the domain? Well, we already know what the domain is. Back from when we talked about it up here, the domain is going to be the intersection of the two domains that we already have. And so you go, okay, I want you to think about this. This first one, the domain, it's really, if here's 0, we'll say here's 3. The domain for that one, it kind of looks like this. It's got a little open loop right here, but otherwise it's everything that way and everything that way. Okay, and this other one, oops, that didn't work. This other one, okay, if 0's right here, well, it kind of looks like this. It would have a closed circle right here, and it's everything that way. Okay? So now we're looking for the intersection, the overlap. Where do those two domains overlap? And that's pretty clear. All of, I'm trying to think about how to best draw this or show this, but all of this is not on the other one. And then, so there they match, except this one, you can't have 3. Okay? So that means we're good with everything going this way, everything, 0 and bigger, except for this 3. And so that's how we describe it. We say, well, what's the domain? Well, the domain is everything from 0. Oh, I'm getting a little chubby on that one. Let's try it a little bit thinner. Okay, there we go. The domain is going to be everything from 0, so I do a closed bracket, including 0, up until 3, but then I do a parenthesis, so that way we're not including 3, union, along with everything from 3 to infinity. Okay? Now, please don't freak out over the fact that this says intersection. You're like, wait, Watkins, that says intersection. This says union. What in the world are you doing? Hey. This is the way I describe putting these two together. It's these two regions, okay? And that is literally the intersection. All right, and so that's what it would be. Okay, now, good news is, remember how nice this was? We had the same domains right there. So we do it once. As long as we do it right, we're good. Okay, so now let's do the other ones. This is simple. We're going to do f minus g of x, which is going to be 4 over x minus 3 minus square root of x. Done. What's the domain? Well, everything from 0 to 3, not including 3, and then everything from 3 to infinity, not including 3. Pretty easy. All right, let's try something else. So we'll go f times g of x. And literally, hey, I need to give myself a little more room. Otherwise, it's going to start getting really sloppy. Really sloppier. So you go f times g of x, which is just 4 over x minus 3 times the square root of x. Now, that one I can at least simplify a little bit. And so as to simplify that becomes 4 times the square root of x all over x minus 3. I should at least, these first two, I couldn't simplify. I could go ahead and find a common denominator, but man, it's going to be an uglier fraction than just leaving it like that. But this one, multiplication, you can simplify. But again, the domain is still the same. It's everything from 0 to 3, not including 3, but you can include 0, and then everything from 3 to infinity. All right, and then I've got f divided by g of x, which is going to be a little bit weird, but you're going to say 4 over x minus 3 divided by the square root of x. Okay? You go, oh, fractions and fractions, we hate those. Okay? And so really this is like over 1. Can you see that? So we got a fraction right here. The fraction right here is 4 over x minus 3. We got a fraction here, square root of x over 1. And when we said when we're dividing fractions, we flip and multiply the second one. So we have 4 over x minus 3. And then we take this other one, we flip it, and it becomes 1 over square root of x. And we can distribute that and get, 4 over x times the square root of x minus 3 times the square root of x. And that's ugly all day. Okay. So we got to ask ourselves, how does the domain change? If we go back up here, we remember that the big change in the domain was this. We have to go whatever makes g of x equals 0. It doesn't matter how ugly and convoluted this thing right here got. It doesn't matter. We have to just go back to, what would make g of x 0? And that thing we can't include. Well, the function g of x is just the square root of x. Well, when do you get an output of 0? You get an output of 0 when you put in 0. So you go, oh, that's easy. So now we just can't include 0. Simple. So we go 0 to 3, not including either one, union along with 3 to infinity. Sweet. That's easy. Okay. All right. So now it's your turn. Okay. Now it's your turn. So let's see here. Let's try something. I don't want to go too crazy. But it's worth, trying to have at least some fun with it. So how about we do this? It's your time. We'll go, okay. Let's let f of x equal, see, I don't want it to be too insane, but they're just so simple. I mean, you look back at there and you go, man, adding them, subtracting them, multiplying them, it's just not hard. So let's let f of x equal the square root of, I'm going to say x plus 1, okay? And let's let g of x equal 1 over x, okay? That's a good pair. That's a good pair. So then what I want you to do is I want you to do the exact same thing. I want you to go ahead and find f plus g of x, f minus g of x, f times g of x, and f divided by g of x. And their domains. Don't forget that. Domains. Okay. So what we're going to do is we're going to pause the video right here. You can take a few minutes. Probably only take about 3, 4, 5 minutes. And you can do it. All right. Go for it. So we'll pause the video and then we'll work on these problems. Okay, and we're back. Let's see this. So hopefully you did it the same way. The very first thing we did on the other one is we said, okay, well, let's just take a look at f of x all by itself. We got this idea of this x plus 1. We know that everything under here has always got to be at least 0 or bigger. So we say, well, x plus 1 has to be greater than or equal to 0. And then we can solve from there and go x has got to be greater than or equal to negative 1. And so that is our domain, okay? That's our domain. That's nice and easy. Our domain is just x has got to be greater than or equal to 0. Okay, let's do g of x. G of x equals 1 over x. Now, this one's lame. No radicals in it. And you go, what makes the bottom 0? I don't know, 0. And so that's so simple. X cannot equal 0. Easy. Okay? So there's our domains. So let's get to work. So we say, well, f plus g of x equals f, square root of x plus 1, plus g, 1 over x. And that's it. And so with this, all we got to do right now is go ahead and find the domain. And the domain is the overlap or intersection of these two functions. And so all I have to do is go, okay, well, what was the domain? And we didn't stop and do that. Maybe, we talked about it right here. Let me see. Sorry, let me give myself a little bit more room. Because while I found the domain, I didn't illustrate it. And I think sometimes illustrating it helps. Okay. So I'm going to say here's 0, here's negative 1. We said the domain for this one was, we can fill this in and we're good with everything bigger than this. Okay. All right. And for this one, you think about what that one would look like. Here's the number line. Here's 0. And I don't know if you're tracking, but if x can't be 0, well, then it can just be everything back this way. Okay. And then everything out this way. And the only thing it can't be is 0. Okay. All right. So then we go, where do those overlap? So let me bring this one. Oh, yeah, that'll work. Where do those overlap? Okay. Well, it looks like we're good with everything from, whoa, that was weird. It looks like we're good with everything from negative 1 going positive, except for 0. We gotta take that out. Okay, so there's this little bit that we're good in between negative 1 and 0, and we're good with everything bigger than 0, okay? And so the domain would be like this. It would be negative 1 to 0, including negative 1, but not including 0, along with everything from 0 to positive infinity. And I don't want to write in red anymore, okay? Boom, there we go. All right. All right, let's keep going. So we go f minus g of x is equal to, this is easy, square root of x plus 1 minus 1 over x. Lame. Negative 1, 0, not including 0, along with 0 to positive infinity. Okay, oops, that's a g. F times g of x is equal to square root of x plus 1 times 1 over x, and that simplifies to the square root of x plus 1 all over x. Okay? But that doesn't change anything. The domain is still the same. -1 to 0, not including 0, all the way from 0 to positive infinity. And then we get to f divided by g of x, which is equal to the square root of x plus 1 all over 1 over x. We said we don't like to divide with fractions, so we flip and multiply, and it actually becomes x times the square root of x plus 1. Now, here's the big hiccup. When people see this, all of a sudden we don't have a fraction anymore. So we go, wait a minute, can we now include 0? We don't have a denominator, so can we? And I really wish I was there in class to see your faces and actually have this discussion, because this is a great discussion. And the weird bottom line is, at once we did have a denominator. There was a denominator where x was in the denominator. So no, we cannot include 0. Just because the whole thing kind of got flipped and it doesn't have a denominator now, it did at one point before it was completely simplified. So it can still not have that 0. Now, the other weird thing about this one is, what x value do I plug in so that this is equal to 0? And the answer is, it's impossible. It doesn't matter what number I plug in here, I'll never get 0. 1 over anything, 1 over, 1,000 is pretty small, but it's not 0. 1 over 1 million, again, is really small, still not 0. There's no number that I can put in the bottom that makes that equal 0. So that's good news. So that's what's cool about that, and I wish, again, that I was there to see your faces and talk to you, is that means there's no additional value that I have to take out. It's just -1 to 0 along with 0 to infinity. Yay! All right. So hopefully that makes sense. All right. I'm going to stop right here for a second, but you're going to pick up on the next video in like 2 seconds. I'm just breaking it up, and we're going to talk about the other way to combine functions. Stay tuned.